Summer in China is turning megacities into enormous concrete blocks that absorb heat. Road surface temperatures can exceed 60 degrees Celsius, rooftops retain heat for hours, and millions of air conditioners operating simultaneously consume more than 47 million kilowatts of electricity, putting unprecedented pressure on the grid. But instead of simply installing more air conditioners, China is turning entire cities into massive cooling systems. In outdoor public squares, ultra-fine mist can cool the air without getting pedestrians wet. Beneath commercial districts, centralized cooling plants quietly distribute chilled water to dozens of buildings. On rooftops and roads, special coatings are quietly reflecting heat back into the sky. China is gradually turning its battle against extreme heat into a multi-layered defense system. So what technologies are actually helping these enormous cities cool down? Join Mandarin Tech as we explore them in today's video. The turning point came in the summer of 2022, when China experienced one of the most severe heat waves ever recorded. High temperatures persisted for more than 60 days. Many heat records that had stood since 1961 were broken. Water levels in the Yangtze River dropped sharply. Cracked and dried riverbeds appeared in some areas, and hydropower reservoirs gradually lost their ability to supply energy. In Sichuan, hydropower output plunged just as demand for air conditioning surged. Some factories were forced to halt production to prioritize electricity for residential use. The hotter it became, the greater the demand for cooling. But the more the country relied on air conditioning, the greater the pressure on the power grid. It was this crisis that pushed China to shift its focus from cooling individual rooms to controlling heat on an urban scale, turning entire cities into giant machines built to fight the heat. A black road may look like nothing unusual, but under the summer sun, kilometers of asphalt can act like a giant heat collector stretching across the city. By mid-afternoon, surface temperatures can exceed 60 degrees Celsius. Under more extreme conditions, they can even approach 70 degrees Celsius, hot enough to cause skin injury after brief direct contact. Throughout the day, these surfaces continuously store energy like a giant battery being charged. After the sun sets, that heat does not disappear immediately. Instead, it is slowly released back into the air, causing streets to continue radiating heat for hours. To limit this process, some Chinese cities have begun testing cool pavements. Instead of allowing dark asphalt to absorb nearly all incoming sunlight, the surface is coated with light-colored materials capable of reflecting part of the solar radiation back into the atmosphere. The goal of this technology is not to turn streets into cold surfaces. Reducing temperatures by just a few degrees across millions of square meters can significantly change the amount of heat an entire city absorbs and later releases back into the air. Cooler pavements help pedestrians endure less direct heat, reduce the amount of heat released at night, and ease the load on air conditioning systems inside buildings. However, these coatings must withstand friction from vehicles, dust, rainwater, and continuous temperature changes. If the surface deteriorates quickly or loses its reflective ability, its cooling effectiveness also declines. In Shenzhen, instead of allowing dozens of buildings to operate thousands of outdoor air conditioning units independently, planners chose to connect them to a shared network capable of providing cooling for an entire urban district. Several floors beneath the ground, they built an underground plant roughly the size of a football field. Inside, high-capacity chillers, pumps, heat exchangers, and a massive network of pipes occupy almost the entire space. Instead of cooling each building separately, the facility produces chilled water on a scale large enough to serve an entire urban district. The process begins with water being chilled at the central plant and then pumped through an underground pipe network to each building. There, the chilled water passes through heat exchangers and absorbs heat from the building's cooling system. That heat is carried back to the plant by the water, while the building's internal system continues producing cool air and distributing it to offices, hotels, shopping centers, and other spaces. The water then returns to the plant to be chilled again and begins another circulation cycle. From above, The commercial district still appears to consist of dozens of independent towers, but underground, they are all connected to the same enormous cold bloodstream. According to published figures, this model can serve nearly 3 square kilometers of buildings and save more than 130 million kilowatt hours of electricity per year, equivalent to 16,000 metric tons of coal being burned. As the cooling demand of each building changes, the central system automatically adjusts its capacity according to actual load, allowing it to operate more efficiently than thousands of smaller units working independently. Cooling the ground alone is not enough. The space above must also be cooled. But it is impossible to install an air conditioner to cool a public square. Therefore, on some pedestrian streets, public squares, and tourist areas in China, high-pressure misting systems are installed above pedestrians, creating fine clouds of mist that cover the area below. People can walk through the mist and feel cooler air while remaining almost completely dry. The secret lies in the size of the water droplets. High-pressure pumps force water through extremely small nozzles, breaking the liquid stream into countless droplets much smaller than ordinary raindrops. They are so light that they remain suspended in the air and begin to evaporate before they can reach the ground. To change from a liquid into vapor, water needs to absorb energy. That energy is drawn from the surrounding hot air. When millions of water droplets evaporate at the same time, the temperature within the area can drop by 5 to 8 degrees Celsius in a short period of time. The misting system does not attempt to turn the entire area into an air-conditioned room. Instead of large compressors and refrigerants, the system mainly requires water, pumps, and a network of nozzles. Across large areas, dozens or even hundreds of nozzles can operate simultaneously, creating a cooling layer that covers the square like a giant air conditioner without walls. However, its effectiveness depends heavily on environmental conditions. In excessively humid air, water evaporates more slowly and the cooling effect decreases. The system also requires a clean water supply to reduce mineral deposits that could clog the extremely small nozzles. At midday in summer, rooftops can become some of the hottest surfaces in a city. They absorb solar radiation for hours, store heat, and then transfer it into the interior, forcing air conditioning systems to work harder. To limit this process, China is experimenting with passive radiative cooling coatings. The surface is designed to reflect most sunlight before that energy can be converted into heat. At the same time, the heat already absorbed is emitted as infrared radiation and escapes through the atmosphere into outer space, allowing the surface to continuously release heat even during the daytime. When the amount of energy released exceeds the amount of heat absorbed, the roof surface can maintain a significantly lower temperature than conventional dark-colored materials. Under suitable conditions, it can even become cooler than the surrounding air in broad daylight without requiring compressors, refrigerants, or electricity to operate. In Hong Kong, a research team has developed a commercial version of this technology. In some published applications, the coating can help reduce indoor temperatures by around 10 degrees Celsius and save nearly 40% of the energy used for cooling. However, actual performance depends on the roof structure, coated area, weather conditions, and ventilation. Dust, rain, ultraviolet radiation, and repeated heating and cooling cycles can also reduce reflectivity over time. If applied across thousands of rooftops, this technology could reduce the amount of heat accumulated by individual buildings and help cool the entire urban area. During the heat wave of 2022, China faced more than just high temperatures. Drought caused river levels to fall, reservoirs to weaken, wildfires to break out, and hydropower output to plunge just as electricity demand for cooling was rising. To obtain more water from the sky itself, authorities used cloud seeding technology to encourage rainfall. An important component is silver iodide, a compound with a crystal structure similar to ice. When introduced into clouds that already contain moisture, these particles provide surfaces for water vapor to attach to and freeze. The small crystals continue to attract more water, gradually growing and joining together. When they become too heavy for rising air currents to support, they begin to fall and may melt into raindrops before reaching the ground. In some areas, small rockets are launched from the ground to carry seeding material into the clouds. China also deploys large aircraft capable of operating for hours and dispersing cloud seeding material across areas covering thousands of square kilometers. However, the technology only works when clouds already contain sufficient moisture and suitable meteorological conditions are present. It accelerates a natural process that is already close to occurring, rather than creating rain as precisely as flipping a switch. Even so, rainfall arriving at the right time can produce a major effect. Rainwater helps cool the air near the ground while also replenishing rivers, reservoirs, agriculture, and hydropower plants that supply energy to the very urban cooling systems themselves. In a conventional city, rain falls onto concrete rooftops and roads, then is quickly channeled into drainage systems. Just a few hours later, most of that water has already left the urban area, while the ground continues to dry out and heat up under the sun. China is trying to reverse this cycle through the sponge city model. The initial pilot program was implemented in 16 cities and later expanded to 30 urban areas. The goal is that by 2030, more than 80% of urban built-up areas will meet sponge city standards, with the capacity to absorb and reuse around 70% of rainfall on site. Instead of rapidly draining rainwater out of the city, infrastructure is designed to retain, clean, and reuse it. When rain falls, some of the water seeps through porous paving surfaces and flows into the stone layer underneath. In parks, low-lying areas can temporarily become retention ponds. After the rain, the water is slowly released into the drainage system, allowed to seep into the ground, or collected for watering plants and cleaning streets. The value of this system also lies in its cooling capability. Water retained in the soil, ponds, and vegetation becomes a natural thermal reservoir, helping urban surfaces retain moisture and stay cooler during the sunny days that follow. With a sponge city, rainwater no longer disappears immediately after a storm. It is retained beneath the city, becoming a layer of protection against two increasingly severe extremes: intense flooding and prolonged heat waves. The previous solutions all cool an area, a building, or even a large open space. But what happens to someone who is simply walking, waiting, or standing under the sun with nowhere to take shelter? That is why independent outdoor cooling devices have begun appearing in some public spaces across China. They can be installed at bus stops, railway stations, tourist areas, or crowded public squares, creating small cooling zones in open environments. A single device can combine a canopy, ventilation fans, a misting system, seating, and electronic amenities. Electricity can even be generated directly on the roof using solar panels. In Tianjin, the hottest periods of the day, when cooling devices are needed the most, are also when sunlight is strongest. And that is also when the solar panels generate the most electricity. Instead of having to run indoors to escape the heat, a more comfortable environment is brought directly to you on the street. On the streets of China during the summer, personal cooling devices are appearing in many different forms. The simplest type is a handheld fan with a small water reservoir. When operating, the device releases a fine mist into the airflow, combining air movement with evaporation to draw heat away from the skin. For workers who spend long hours outdoors, fan-equipped clothing creates a continuous flow of air inside the fabric, helping sweat evaporate faster and allowing the body to release heat more effectively. More advanced are neck-worn cooling devices that use Peltier semiconductor modules. When an electric current passes through them, heat is transferred from one side to the other. The side in contact with the skin becomes cooler, while the opposite side must dissipate heat through metal heat sinks or small fans. The greatest advantage of these devices is their flexibility. Cooling moves with the user and is focused directly on the body instead of cooling an entire railway station, factory, or large construction site. China is not trying to find a single machine powerful enough to defeat extreme heat. Instead, it divides the problem into multiple layers, reducing heat on rooftops, limiting heat absorption by streets, cooling public spaces, managing water resources, and centralizing cooling for entire urban districts. China's battle against extreme heat is not taking place in a single location. When combined, each technology becomes part of a massive defense system against increasingly severe weather conditions. In the future, modern cities may no longer be judged by the number of air conditioners they use, but by their ability to stay cool with less electricity, fewer emissions, and less waste heat. Do you think major cities in other countries should also build centralized cooling systems like these? Leave your thoughts in the comments below and subscribe to Mandarin Tech to keep exploring the technologies and infrastructure quietly keeping the world running.